You have probably held a piece of space in your hand without ever knowing it had a smell. Somewhere out there, in a drawer or a rock shop bin, sits a meteorite that streaked through our sky, trailing the odor of rotten eggs. And that's the mild end of tonight's catalog. At the far end, sitting at the exact center of our galaxy, there's a cloud of gas that tastes like raspberries and smells like rum, laced with a molecule that would kill you before you finish the sentence. None of this is metaphor. Every specimen in this video was chemically sampled, spectroscopically confirmed, or smelled firsthand by a human being who was actually there. Space is supposed to be an empty vacuum with nothing in it to smell at all. It turns out it has been quietly manufacturing odors for 13 billion years, and we're about to walk through every layer of it, from the faintest trace to the one sitting in our galaxy's own heart. Number 1. The meteorite in your hand. We start with the specimen you might already own without realizing it. Certain meteorites, chunks of shattered asteroid, and in rare cases actual fragments blasted off the moon or Mars, carry a mineral called troilite, an iron sulfide that begins reacting the moment it meets our air. Scratch a freshly fallen one, or just let it sit somewhere warm, and it gives off a sharp, unmistakable whiff of rotten eggs and spent gunpowder. It's distinctive enough that meteorite hunters actually use it as a field test, a smell that separates a genuine visitor from another chunk of ordinary Earth rock. Picture striking a match at the back of a mining tunnel, and you're close. Here's the part that makes no sense. Some of these rocks are older than the sun. They condensed out of the very same cloud of dust and gas that later built our entire solar system, which means they've been sitting in the dark, chemically untouched, since before Earth existed. That smell in your palm isn't from the fall through the atmosphere. It's a seal being broken on something that predates our planet, cracked open the second it finally touched our air. That's a rock quietly reacting to a world it was never built for. But go up and meet that same emptiness directly, and something stranger starts clinging to you. Number 2. The vacuum of space itself. Nobody has ever smelled the vacuum of space and lived to describe it. Breathing, it would kill you in under 15 seconds. But astronauts returning from a spacewalk keep reporting the same thing. Their gloves, their tools, the outside of their suits, all carry a sharp, unmistakable odor the moment they're back inside the airlock. Describe it enough times and the same words come up again and again. Hot metal, seared steak, the acrid tang left behind after welding. The leading explanation is almost poetic. In low orbit, a suit's outer layer picks up atomic oxygen, single unpaired oxygen atoms, far more reactive than the oxygen you're breathing right now. The instant that suit is pressurized back inside the station, those atoms recombine into ozone and a handful of other compounds. And that reaction is what astronauts are smelling. It's not a scent from space. It's the smell of space chemically reacting with the one shield keeping a human being alive inside it. So the vacuum itself has no odor. It's a void, and a void has nothing to carry a smell on. But the moment something crosses back out of it, it comes home wearing the fingerprint of the trip. And nowhere does that fingerprint linger longer than inside the place where astronauts actually have to breathe it in. Number 3. Inside the space station. Astronaut Don Pettit described it as a smell that would tickle the back of his nose every single time a crewmate came back in from outside. Sharp, metallic, somewhere between a blowtorch and a well-done steak left too long on the grill. It fills the module fast, because up there, nothing disperses it. There's no wind, no convection currents pulling it away through an open window. In microgravity, a smell doesn't drift off. It just clings to the walls, the vents, the inside of your own nose, until the air scrubbers slowly grind it out. Here's the detail that turns a gross smell into something almost beautiful. One leading theory points to polycyclic aromatic hydrocarbons, PAHs, complex carbon molecules that also happen to be some of the most common organic compounds floating between the stars, forged in the final dying breaths of ancient stars billions of years before our sun ever ignited. If that theory holds, the burnt steak smell that fills the space station after every spacewalk may be, quite literally, the leftover perfume of a star that died long before Earth was born. That's the smell clinging to a spacecraft built by human hands. Number 4. The moon. 12 people have walked on lunar dust, and every single one of them, without exception, came back inside the lander describing the exact same thing: spent gunpowder. Buzz Aldrin called it wet ashes. Harrison Schmitt, a trained geologist on Apollo 17, was blunt about it. His first instinct, and everyone else's, was that they were smelling a fired rifle. Here's why. Lunar dust has never been softened by wind or rain, because the moon has neither. It isn't rounded and smooth like beach sand. It's sharp, glassy, and jagged, shattered by billions of years of micrometeorite impacts, and never once weathered down. That dust clings to spacesuits by static, gets tracked back into the cabin, and the instant it meets the ship's oxygen-rich air, it begins to oxidize. A chemical reaction the powdery, never-exposed regolith had never experienced in over 4 billion years of sitting untouched on the surface. Which means that gunpowder smell wasn't a relic of the moon at all. It was a brand new reaction, happening for the very first time, inside a spacecraft, because 12 human beings dragged a piece of the moon somewhere it had never been. We've walked on it. We've smelled its dust firsthand, and it's the last stop on this list where a human being has actually been present to confirm the odor with their own senses. From here on, every specimen was reconstructed from a distance, by machines standing in for a nose no one could risk bringing along. Number 5. Mars. No human being has ever stood on Mars and taken a breath, so nothing here is a first-hand report. It's a reconstruction, built from decades of rovers scooping, baking, and analyzing the dirt beneath their wheels. But the ingredients are well documented. Martian soil is soaked in iron oxide, the same compound that gives rust its color and a dropped penny its metallic tang in your mouth. Layered on top of that are perchlorate salts, reactive, faintly acrid compounds toxic enough that any future astronaut will have to scrub them off before setting foot inside a habitat. Plus, sulfur compounds baked directly into the regolith. Put it together and you get something like a rusted iron gate left out through a thunderstorm, dusted with the ashy sting of a just-struck match. Fine, and it would coat everything. Your gloves, your visor, the inside of any airlock that ever let Martian dust through. Here's the honest caveat, and it matters. Unlike the moon, nobody has smelled this yet. It's chemistry standing in for a nose, an educated guess dressed up as a fact. But that's about to change, because Mars is the last stop where we're still guessing based on soil in a scoop. Push further out, and we start relying entirely on machines that flew straight through the smell itself. Number 6. Titan. Saturn's largest moon is wrapped in a haze so thick that the Cassini spacecraft couldn't see the surface at all until its Huygens probe physically punched through the orange smog and landed. That atmosphere is built almost entirely from hydrocarbons, methane, ethane, and a tar-like family of organic molecules called tholins, the same broad chemical family that makes up gasoline, diesel, and asphalt here on Earth. If you could somehow stand there and breathe it in, you couldn't. The cold alone, nearly minus 180 degrees Celsius, would kill you before the chemistry even had the chance. The air around you would carry the same bass notes as a gas station forecourt, except stretched across an entire moon, permanently, with rivers of liquid methane running through the haze instead of water. Here's the part that reframes the whole picture. Some of the exact organic reactions happening in that thick orange fog echo the same prebiotic chemistry scientists believe kick-started life on Earth billions of years ago. That gasoline and tar smell isn't just industrial pollution dressed up as alien weather. It might be the closest thing in our solar system to the raw chemical soup life itself was cooked from. That's a moon whose atmosphere smells like a refinery, quietly running the recipe for life. The next world on this list smells like something actively trying to kill you the instant you'd notice it. Number 7. Venus. Venus is wrapped in clouds of concentrated sulfuric acid, and hanging in that same atmosphere is sulfur dioxide, the same pungent burnt match gas that stings your throat the second you smell it on Earth, except here it never clears. The surface underneath sits at nearly 470 degrees Celsius, hot enough to melt lead outright, crushed under air pressure 92 times what you're feeling right now. Roughly the same weight as standing under nearly a kilometer of ocean. Here's the detail that makes Venus different from everything before it on this list. You would never actually register that smell. Between the heat and the pressure, a human body would be cooked and crushed within seconds of exposure, long before any signal reached a working nose to process it. Every other specimen so far, however faint or however far away, could theoretically be smelled and survived, at least for a moment. Venus is the first entry on this catalog, whose smell exists purely as a chemical signature captured by an orbiter, a burnt match odor that will spend eternity being real and never once being noticed by anyone who lived to describe it. So the harshest environment yet turns out to be a place with no witness at all. But travel further out, past the rocky worlds entirely, and you start finding an odor detected directly in the clouds of an actual planet. Not inferred, not guessed at, but caught red-handed by a telescope on the ground. Number 8. Uranus. In 2018, a team led by Patrick Irwin at the University of Oxford pointed the Gemini North Telescope's near-infrared instrument at Uranus's upper clouds and found something nobody had confirmed before: hydrogen sulfide, the exact compound responsible for the smell of rotten eggs, sitting in the planet's atmosphere in measurable quantities. This wasn't an educated guess built from soil chemistry or atmospheric modeling. It was light, bounced straight off the planet itself, carrying a chemical signature as unmistakable as a fingerprint. Picture descending through Uranus's cloud deck, the smell of 1,000 rotten eggs thickening around you while the temperature drops toward 200 degrees below zero, and the pressure climbs high enough to crush a submarine hull. Uranus has been the punchline of every schoolyard joke about planetary names for decades. It turns out the joke was true chemistry all along. We just needed 50 years of telescopes to actually prove the planet reeks. That's an entire world confirmed, from Earth to smell exactly as bad as the internet always assumed. But there's one place in this solar system where we didn't have to squint through a telescope at all, where a spacecraft flew directly into the smell and radioed back exactly what it found. Number 9. Comet 67P. In 2014, the European Space Agency's Rosetta spacecraft caught up with Comet 67P, Churyumov-Gerasimenko, and parked itself close enough to sample the thin cloud of gas boiling off the comet's surface, using an instrument called Rosina. What it found reads like a chemist's idea of a punishment: hydrogen sulfide, the rotten egg compound we just met on Uranus; ammonia, the sharp sting of a horse stable that hasn't been cleaned in years; hydrogen cyanide, carrying the faint bitter almond note of a poison; sulfur dioxide's burnt match sting; and formaldehyde drifting through the whole mixture like the smell of a preservation lab. ESA's own scientist nicknamed it, only half joking, the comet's perfume. And the honest verdict from the mission team was that if you could actually smell it, you would wish you hadn't. Here's what makes it worse than simple filth. Comet 67P is a barely altered leftover from the construction of the solar system itself, roughly 4.5 billion years old, and essentially unchanged since the day it formed. This isn't decay, it's the raw, unrefined ingredient list every other planet, moon, and rock on this catalog was eventually built from, still sitting in its original, unedited state, chemically identical to the moment it first came together. So the worst smell in this entire catalog turns out to be the oldest one, the source material everything else on this list was distilled from. But take those exact same raw ingredients, carry them tens of thousands of light years inward, and pack them into the crowded, violent center of our own galaxy, and something almost impossible happens to them. Finale, the center of the Milky Way. Roughly 26,000 light years from where you're sitting, near the crowded, chaotic core of our own galaxy, there's a giant cloud of gas and dust called Sagittarius B2. In 2009, a team led by Arnaud Belloche at the Max Planck Institute for Radio Astronomy, working with researchers at Cornell and the University of Cologne, pointed the IRAM 30-meter radio telescope in Spain at that cloud, hunting for the building blocks of amino acids. What they found instead was ethyl formate, the exact molecule responsible for the flavor of raspberries and the smell of rum, drifting in genuinely enormous quantities at the heart of our own galaxy. Here's the part that turns wonder straight back into dread. Sitting right alongside that sweet, boozy molecule, in the same cloud, at the same coordinates, is N-propyl cyanide, a close chemical cousin of the poison that gave Comet 67P its bitter almond note, except here in far greater concentration. The center of our galaxy is, quite literally, a bakery attached to a distillery, laced all the way through with cyanide. Sit with the shape of that. The rotten egg reek clinging to a meteorite in your palm. The gunpowder dust tracked into a lunar lander. The burnt match sting hanging over Venus that no living thing will ever notice. And the raspberry-and-rum heart of our entire galaxy, poisoned in the same breath it sweetened, are all the exact same story, told at wildly different scales. No design shaped any of it. No one built these smells on purpose. It's the same handful of simple molecules, sulfur, carbon, nitrogen, oxygen, rearranging themselves over and over, everywhere gravity and heat and time give them the chance, sometimes into a stench, sometimes into something you'd want to bottle, and sometimes, somehow, into both at once. So the next time someone tells you that space is empty, silent, and odorless, you'll know better. It has a scent, rotten eggs on your own front porch, gunpowder tracked across a lunar lander, and somewhere out past 30,000 light-years of dust, the smell of rum wrapped around a poison, right at the center of everything. If you made it all the way to the middle of the galaxy, comment raspberries so I know you stayed for the whole catalog. And if this list changed the way you'll think about that meteorite in your local museum, leave a like. The algorithm only knows you finished if you tell it.